All right, folks, here we go. This is the last notes for the whole year 2023. Okay, we're just going to review some of the properties and then we're going to mix them together with what we learned yesterday about fraction powers. So remember, in this situation, when you're multiplying the same bases, you add the power. No big deal. When you have them top to bottom, I always kind of think of it as canceling. You can think of it as subtracting, but like in this case, you get a -3. So you have to move that into the bottom. I always kind of think of it as like between the 7 and the 10, you have 3 extra. And since there were more on the bottom, they will go on the bottom. But it's technically still subtraction. When we had this scenario, we ended up having to take the 5 on the inside times the 2 and getting x to the 10. And here, when there was more things than just one, we distributed the power, but we only distributed 2 powers. So 12 is the tempting but wrong answer because we need 3 to the 4. X to the 8 and y to the 4th. So 3 to the 4, what's that? 243. You can use your power chart. And then over here, again, these, you can think of it as subtraction if that makes you happy. Or you can, again, think, okay, well, there's 3 extras, and because there were more on the top to begin with, then I'm just going to leave the extras on top. Here, this 4 gets distributed, but again, power is only multiplied by power, so it's not 3 times 4, it's 3 to the 4th. And then this will be x to the 8 over y to the 4th, because it's currently just a 1 power. And 3 to the 4th is still 243. No, I bet it's not. I bet it's 81. Oh my gosh, I went 1 power too high. So then JK on that. And let's zoom back over here and make this perfect. Because I just got overzealous and went 1 power too high. Sorry. Math is hard. Okay, so we learned about fraction powers, and here is just a combo of what we already know. You know that if you have the same base, you need to add the powers like we just reviewed. Here's the other thing. When you add fractions, this is the part you're not going to love. You need a common denominator. In this particular problem, I have a common denominator, so I can just go ahead and add them. And I end up with 3 to the 8/7 is my answer. So the problem will be if you don't have a common denominator, you're going to have to figure that out. All right, how about over here? Just like up in this example above, I have fraction on the outside, a power on the outside and a power on the inside. So I'm going to multiply them. When you multiply fractions, you multiply the top, so 1 times 2, and you multiply the bottom, 2 times 5. So that's 10. We do need to be able to reduce, and that would reduce to 1/5. This one's kind of scary because it's negative. What does a negative do? It moves everything from the top to the bottom. So the first thing I would do is move the 3 to the top and the 2 to the bottom, and then my power becomes positive. And that's all I need to do because I'm simplifying to as much as I can. No negative powers in that. This looks terrifying, but if you see they're both 6s, and then we're going to look at the powers. Now, normally we would subtract or figure out, how many are left. If you want to think of it as subtraction, you would have 2/3 minus 7/3. You'd end up with 6 to the -5/3, but you would end up having to write that as 1/6 to the 5/3 because of that negative power. Or you can look and say the difference between these is 5/3, and then the extras will go wherever you had more, and you had more on the bottom, the 7 versus the 2. So you're going to have those 5/3 extras on the bottom, and so I would still write it as 1/6 to the 5/3. The base doesn't change. So like here we had a base of 8, it's still 8 as we go through. Here we had a base of 3, it stays 3 the whole time. Then over here, I have a base of 3, so I will have a 3. And in this case, I have to add my powers, but now our luck has run out. I don't have a common denominator, and I need one. A number that both 2 and 3 will go into is 6. So In order to turn them each into 6, to make 2 into 6, I have to multiply it by 3, so I do that to its top. In order to make 3 into 6, I have to multiply it by 2, so I do that to its top. So ultimately, I end up with my base of 3 from here. 3 plus 2 is 5 sixths. And so I end up with that. Oops, I'm also still dumb because 2 times 2 is 4. So I am going to have 7 over 6. I'm kind of riding the struggle bus today. I'm doing this over my lunch, and so I'm trying to hurry. And being fast is turning out to be a bad idea. All right, same thing. Now I don't have a number base, I have a letter, but I still do the same thing. I'm going to add these together. I need a common denominator with 2 and 4. The common denominator is going to be a 4. To make this into a 4, I need to double it, so I double its top. Turns into 2. The 1 I don't have to adjust because it was already over 4. So ultimately, I have my x to the 3/4 power. So this one, I'm going to distribute this power. So I had 2 to the 1, and I'm going to multiply it by 2. I had x to the 3/2, but I'm multiplying it by 2, which is like 2 over 1. I had y to the 1/4, but I'm multiplying it by 2 over 1. So I end up with 2 squared, which is 4. I end up with x to the 6 over 2, which is a 3rd power because you reduce. And here my y is going to have a 2 over 4 power, which reduces to 1/2. So you kind of take one step to see what they equal and then one step to go ahead and reduce those. All right. So this is negative. I'm going to go ahead and distribute still. So I have x to the 8. Because it's a whole number, I can think of it as being over 1. I'm multiplying it by a negative 1/2. I had y to the negative 3 power, and I'm multiplying it by negative 1/2. So this one turns into negative 8 over 2 power. This turns into positive, because the negatives cancel, 3 over 2. And this is the only one that reduces. But because it's negative, I can't have it in that spot. It has to move into the bottom. I don't have a bottom, so I create a bottom, and I put that x to the 4 there. So this is tricky, but it's all things we've already done. The rules combined with fractions. All right. So these are really hard to do as is. So one thing that might help is to remember that this really means the same thing as to the 1/3 power. That's what this cube root would mean. And then you can distribute that. You would have 64 to the 1/3, x to the 6 times 1/3, which is 6 over 1. You can look up this cube root of 64 on your card, and you'll find out that that's a 4. Here I have x to the 6 over 3 power, which ends up being 2 when I reduce it. Except for it's a y, so I wrote an x for no good reason, because I can't even read my own writing. Okay, so this is going to be distributed to all the powers. So I'll have 27 to the 1/3, which I can do on my card because it's the same as a cube root. That turns into a 3. I had a 3rd power here, but I'm multiplying it by 1/3. I had a 12 power here, but I'm multiplying it by 1/3. So it becomes p to the 3 over 3, which is just p to the 1st. This becomes q to the 12 over 3, so q to the 4th in my final answer. And then this one looks like it's going to completely freak you out. The number part I'd probably still think of as a radical, because then I can look on my chart and say, oh, that's just going to be a 2. But the rest of it, like, I would probably just go ahead and think of this as being to the 1/4 power because of this. Then when I distribute, I'll have k to the 3 times 1/4. I'll have m to the 6 times 1/4 over n to the 8 times 1/4. K to the 3/4 does not reduce. This would turn into 6 over 4, which would reduce to 3 over 2 on the m. And on the bottom, this would turn into n to the 8 over 4, which would become n squared. So obviously, if you're not comfortable with fractions, this is going to be a tricky little business. But that's the whole kind of idea, is to revisit all those concepts and get a little better at that. Hopefully that helps.